All right. So once Ethan comes in here, we're gonna need math journals out, and if your math journal is not graph paper, you need graph paper. So if you need to grab graph paper, there's graph paper right up here. There's also graph paper right over here. There's graph paper all over the place. There's gonna need graph paper. Then you have to decide as your pairs or your group of three, one person is going to get to talk and be the describer. One or two in the group of three, person or people, are going to listen and draw, and then the listeners will have an opportunity to ask questions to clarify. But at first, they must just listen. So make that determination now. Figure out who's doing what. There's a describer and a listener. Do you want to describe or do you want to listen? If you are the describer, raise your hand. Keep this secret. Do not let her see it. Okay? So you need to try to so you can raise your hand.
Did she let me see it?
So you swing around here to this side so you can't see this. Keep this secret. So I don't think they can see through it. Don't bend these or crease these, please. I'm going to use these multiple years in a row. Are you the describer? Yeah. So keep those secret. Do not let them see it. Okay, put something behind it. Here, just, who's the describer? Alright, here's what's up. If you are the listener, you should have a piece of graph paper in front of you. Describers. Do not go in order, because then we'll all be doing the same thing at the same time. Pick randomly from these graphs. You need to try to get your listeners to draw the graph as accurately as possible by just describing it to them. And then I'm sorry, I was checking if I have quadrant graph paper up there. So on all these graphs, they're going to use, no, never mind. Some of them only use one of the quadrants, other ones use multiples. So you're trying to get them to draw these graphs as accurately as possible. Later we will. But so like you don't say, okay, this is K, da da da, whatever. You just start describing it. So think about what we talked about yesterday. Think about what we talked about yesterday. That you cannot give them the math of it. You cannot say, okay, it's the graph of y equals 3x plus 5. Like you can't say that. But you could say, okay, it's a parabola with intercepts here and there, and it's pointing up or it's pointing down. Like you can do all that, but you can't just give them the equation. Make sense? Think about what we talked about yesterday, the types of graphs, how we talk about them. Yeah.
So you can't give like even just the y-intercept or something?
I mean, you can give the intercepts, but you can't just straight up tell them like the equation. Like A, we could just give them the equation, and then they but instead you can say, okay, it's this type of graph. It intercepts here. It has this kind of behavior. Right? You just can't give them the equation. That's essentially the only thing you can't do. So you could give them separately. It's a graph with an intercept here and a slope here, and it's this type of graph, which means the slope never, you know what I mean?
Okay. So you can just repeat these parts, but you can't say exactly. Okay, got it.
So you're trying to, so there are graphs on this page. You're trying to draw what he's looking at.
I have to be really specific to the point where I need to draw the graph and I need to make it very
I would not use a pen to do this.
Can we start now?
Yeah, you're good. Okay. If you don't have questions for me, you're good.
So, wait, are we starting?
Yeah. You can give detailed pieces of content.
Okay. So linear line. So first, we'll make kind of so think like a plane, like a top.
We know it's
linear line.
but it's exponential.
It's going to be 10 long. Okay, see, that helps. Thank you. Actually, it's 20 long. Okay.
I'll just make it.
Let's go to somewhere else.
Alright.
Okay, so basically, it's a mirror. It's like a picture.
So anyway,
Is it like an arrow? Down?
I'm gonna explain in a second. So,
This
the y-intercept of
y.
the vertices
So,
is -3. So,
Exponential.
Anyway,
the y-intercept.
wait a second. Gunner, y-intercept is -1.
How far does it go?
When x is 2, y is 4.
Oh, and that's okay. Thank you for that. But
I need to know how long each step is. Each step is about.
Then you gotta write your scale on there. Otherwise, it's a pseudo scale, 1 to 1.
Each step.
Hey, reminder, if you're using any scale that is not 1 to 1, it must be written on there. If you're using any scale that is not 1 to 1, like 1 block equals 1, if you're using any other scale, you have to write it on there.
Am I allowed to write down
The y-intercept is
You sure he doesn't have the equation, he just doesn't write it. So you're trusting that he can accurately determine the equations based on the visual of the graph.
Close to your line coming from the other side.
Oh, by the way, your objective is for your team to have the most accurate when we get done. Who knows, there might be a prize.
Wait, we're doing how many one
As many as you can.
What?
Yeah, that's why you have a dozen options.
We're doing the bunch graph.
As many as
like
you
one second ago.
Oh, okay.
I can show you mine. So
Y
is it?
exponential.
And this is comparison.
To the right. It goes positive.
Okay, that's
No. Only y. Each step goes more than the other. Yeah, wait. Yeah, like that.
You got 3 more minutes.
Make
Yeah, it goes up.
say, put the scale on the graph, okay?
It just goes up to the top.
Or
It's
like
like
Yeah.
here, like, yeah.
Oh my god, okay.
When you're at that
Now
comment,
you're gonna
got
be Okay, now you're gonna be
Another graph.
Jenny,
Make another graph, okay?
You're gonna be perfect. Go. Thank you.
Next one
Do
is
the same thing you did there, okay? Just make another one.
Oh.
just the street is the dot.
Yeah.
Okay, so the y-intercept
She's really getting on my
Well,
nerves.
we're doing
no, not y-intercept.
Okay. Wait. Okay, so this
Where
is
the
the later
only thing
graph.
that is on the
It does not go through the
y
origin.
So,
It's
sometimes
the
y.
y-intercept. The y-intercept is 1.
Okay,
And the slope is
that's all like.
okay.
No.
So now,
These are mainly more on
Is
classes.
it possible?
you can tell when your graph,
Take a line. It's not hard. Hey, Mr.
Yo!
So, well, if it's in a street graph, can I tell us what the point is?
Yep.
Oh, okay. And the other point is one is a negative like 6.5.
6.5.
Yeah, it's not.
Better be. Alright, I wish I was
2,
how
5,
I'm so slow. Such a slow time.
3, 4.
Wait,
About a minute. About a minute.
What?
This
A minute
slope
what?
is negative, so it must go down.
I know,
Jenny.
Okay,
so my
here.
intercept is 3.
Okay, so this is gonna be make another graph, okay? Thanks.
Step graph. Negative
Okay.
5 to negative 9. 6.
Okay, take a few points and
Negative
draw a
6
line
to.
here.
Okay.
Oh, I see my
So now you're gonna make another linear graph. The y-intercept
And then you can try another one. It's a step.
and
1 minute.
slope is
Hurry up, hurry up.
One minute.
Make another one. Hurry up, hurry up. Any now. Yes, wait, what? One? Okay.
Like, it's like over.
So it just goes through the origin and just make
Well,
a line
Like,
over
why
one
is that like
and
a
then
no,
Okay.
very
Why
not?
why would you say
So,
that?
like,
A line.
like fashion, so, and then that's really good.
Okay, and then
Okay,
go up
next
one.
one, yeah, okay. So now we're doing another discrete
Oh, yes,
line.
no.
Okay.
And then draw another one.
Yes.
Draw another one.
One looks like the origin.
Faster one.
There's 4 points.
Okay,
Like
That's 1 point. Okay.
Yes,
Other
yes,
point
and
is
then
1
do it all the way
point.
down. Do it diagonally.
2, 4. And 3.
That's
Okay,
that's
so
something else.
discrete
That's
graph.
and
Oh.
Like
Oh.
1 point origin.
Oh.
2, 4.
And Time. Alright, so who got one graph? Who got your listeners to do one graph? At least. Who got your listeners to do 2? 3, 4, 5. Okay, so it seems like we all got about 4. Alright, let's check them. Let's check them. So, here's what your graph should look like. Hold up. So these are the first 6, then there's 6 more.
And we did them in order, right?
Yeah, you could bounce around. You could know in whatever order you chose. So hold on, I'll show you the other 6. I don't know if people chose some from the bottom.
Alright. We got all ours right.
So now I heard some frustrations from some people, both from some listeners and from some describers. So now we're all going to take the describer role. So in your math journal, which we need to talk about at some point, but either like if you're keeping a separate notebook or if you're clipping them all in a separate binder, which most of you got that habit last year, just on a sheet of paper, we want to create an entry entitled Describing Graphs.
So just continuing off of yesterday.
Yeah, that's fine. Yeah, I can always just continue the same page or whatever. So date it, so you know we are on today. So 8:30. And our topic is describing graphs. We're in the same place as yesterday, so 1.2.4. Yeah, 1.2.4. I want you to write a description of one of the graphs. Don't say which graph you're choosing, but I want you to write a description for one of these graphs, or more if you reach that point. You guys need another one, probably. You guys might have to share. Two of you are going to have to share. I want you to write as complete of a description as possible.
Like how we did in the games, we can't say like.
So I'll spoil what we're doing here. Once I give you some time to write, I'm going to ask you to read what you wrote and see if everybody in the class can pick which graph you're describing.
Oh no. We kind of generally talk about it too, though, if we think we.
What you wrote. If you were going to mail a letter to somebody, you'd never see them face to face, there'd never be any interaction, you had to describe a graph as completely as possible, without understanding how to give it a formula. How would you describe it?
Should we not do the ones that we did like as a group?
I mean, you can do those again because some people are pretty frustrated. So when you write it, I feel like you'll probably have a better description than when you were just saying it. So when you write it, you think more. Where do the Wolves play?
One.
Ours are better so far.
Because seventh grade, both seventh grades have football tonight. So Wolves play before.
Yeah. Just that, you only for only goals to this time.
Yes.
Yes, I do. No, we keep it hard.
I'm going to try to get to one of the games tonight. I got to take my dog. Alright, so remember back to yesterday, and you can either look in your notebook. You don't need to talk right now, but these notes are going to be a rolling notes document, which is nice because then I can go back to previous days. So yesterday when we were talking about describing graphs, these are some of the words that we were talking about, right? Is it proportional? Is it linear? Is it quadratic? Is it step? Is it discrete? Is it continuous? Like all those different things. Yeah, there's a couple that we didn't even get on here. Actually, I mean, there's a lot. I'm sure we didn't. The only thing you can't give is an equation. So you understand the x and the y axes, but you don't understand how to give it an equation. This is the reality that we're existing in right now. Going to give you a little over a minute, almost 2 minutes left.
Wait, Jordan, how many graphs are we doing?
Just whatever you get done, at least one.
Okay.
One that you can share with the group.
I can tell them one word and they'll know which graph it is.
Yeah,
I
I can say
can
one
do
word too.
Well,
I'm making
okay,
mine more
so
detailed.
yeah, here we only had 12 to choose from, but imagine that you had, you had
Okay.
no
I mean,
parameters.
for mine, I'm
Yeah.
making it very specific besides the part I've given away.
Yeah, so you can't just say like the cubic graph. There's only one cubic graph on
You
here.
can't say
Graph
that.
J, x to the third power.
Oh.
We didn't even have graph
So,
J.
I didn't
Yeah.
know that was
So it's like
what it was
parabolic,
called.
but then you
It's
flip it again.
crazy.
I didn't know what it was called, but I knew what it was. I had seen it.
Now you could say the behavior of the graph is increasing, then decreasing, then increasing again.
Fancy.
Yeah.
Because that's what cubic does. Whoa. Hey, they're reading over there. This is not like paper band time. Alright, who would like to be bold and go first? Koppel, what do you got for us?
So, my graph is shaped like a semicircle.
Okay.
I wonder.
Now, hold up. We have infinitely many graph possibilities. That would not get us to graph L. If you wrote a letter to somebody and they were going to try to draw your graph, they don't have these 12 options.
Yeah, I have more than
Okay, keep going. Then.
So, it stops at the x-axis.
Okay. What do you mean by stops?
It will not continue.
How do I know it's above instead of below? How do I know it's above instead of below?
Because y-intercept and x.
Okay, so continue.
So, its y-intercept is 0, 8. Its x-intercepts are negative 8, 0, and 8, 0. Some of its points are 4, 7, and negative 4, 7. It's nonlinear and it is functional.
Would that get us to draw L?
A similar one, probably.
It's 0, 8.
No.
For the y-intercept.
Well, you could just say it intercepts the y-axis at 8. I mean, you got to be very clear then, because I like that he did that because some people flip around their x's and their y's, even adults, even mathematicians. Like it just is a mistake that sometimes can catch you. So he gave excessive amounts of detail. That's not a bad thing. We like that. Tepper, what do you got for me?
Okay. I chose to describe a discrete graph, and here's the giveaway. It has exactly 3 points visible on the graph.
That wouldn't. Your person's not looking at these graphs, Colin.
There's more.
Listen to the instructions.
Actually, there's four.
Hey, hold up. I got this. So, Colin, take a moment. I'm going to pop over to Ava. Take a moment. You are imagining that you're writing a letter to somebody, and they're just going to start drawing what you tell them. Not that they have this paper to choose from. They're just going to start drawing what you tell them. Now, we obviously have this to choose from because we know we're using the same graphs. Ava, what were you going to say?
Okay, so my graph is a piecewise, and its y-intercept is negative 1, and each step is 1 long, and each step is 1 above the other, and it's linear.
Yeah, so like step height, we sometimes call that. The step height is 1. So step length
Oh,
is 1.
and there's 1 point above the 1 point from the one below it.
Yeah. So that piecewise already kind of covers that, but I like it.
Maybe they don't know what a piecewise is.
Would that get us to F? Is she missing anything? Good, clear, detailed. Jenny, what do you think? Or what do you have? Give us your description.
This graph has no lines, only points on the graph. The first point is at the origin, and the second point is at 1, 1. Then the third point has 2 on the x, like 2 units over on the x-axis, and the y-axis is the third point starts at 3 on the x-axis, and it's 3 squared on the y.
So you not only described the graph, like picture of it, you also described the behavior that you're noticing. That the y is just the x value squared. I like it. I like it a lot. Who else? We're not feeling bold today? Alright, yeah, what do you got?
Okay, so this graph is linear with a y-intercept of 4 and a negative slope of -1.
So wait, sorry, go ahead, go again. You talk quickly and quietly.
Speak up.
Slow down, speak up.
Alright, so this graph is linear with a y-intercept of 4 and a slope of -1.
So, think about being the person receiving that letter. Think about if instead of just receiving a letter, you first get to ask questions. So you are now going to write the original letter. You are going to have to draw the graph of the behavior of whoever is going to send you your graph. And here's the interesting thing. It's a contest. You have been offered a chance to win an all-expense-paid trip, or $1 million, or whatever floats your boat, or a boat, if you want. So there's some. Hold on. There's some prize. Whatever prize could motivate you to give a hoot. So, can we stop talking over me? I'm going to give you plenty of time. So, I need you to list if the only things the person can tell you are answers to your questions. What are the questions you should ask about the graph? Now, hold up. We're going to trade this with a partner, and they can make any graph they want. They're not limited to these 12. So, with unlimited opportunities, what questions need asked to be able to draw the graph? How about it? And you can like discuss with each other, like, oh, what are you asking? You don't have to just do this silently. You got to get them written down. What questions would you ask? Actually, pause that for a second. I'm going to bring you back. Keep that. We're going to do that in a second, but I'm getting ahead of myself. If we were having some graphs described to us, and if you're playing along in your book, we're going to be looking at 160. Let's say Frank writes us a letter. Frank writes us a letter. Now, Frank's kind of lazy.
Is Frank an elephant?
So, Frank's letter says, I've described 3 graphs for you. And here's his descriptions. Graph A, discrete. Graph B, linear, increasing. And graph C, nonlinear and decreasing. So I heard Ava say, I could say 3 words and they'd know what this is. So Frank kind of took the Ava approach, wrote as little as possible. I don't know if this, I mean, we only have 4 graphs to choose from, so we don't have unlimited opportunities. Does this work? Does this let me figure out each graph he's describing? It's like A.
No.
Okay, what's wrong?
There's
What?
multiple.
Oh.
There are multiple discrete ones, and it just is discrete, so it doesn't say anything else about it. It doesn't say if it's going negative or positively. Like,
There's multiple discrete ones. What about B?
oh wait,
Yes.
yeah.
B works here because there's only one linear increasing graph. Although I is increasing linearly, but it's not continuous, so it's kind of hard to. You can't really call that linear since it's discrete. What about nonlinear decreasing?
No.
Why, Gunnar?
Because 3 and 4 are both decreasing, but they're non-linear.
3 and 4 are both decreasing and nonlinear. So, as you think about your questions, think about Frank's description. If you could ask Frank questions before he describes. How about it? I'll give you a couple minutes. You can ask any type. You can ask numerical question. Like you could say, does it like if it has a y-intercept, what is it? If it has x-intercepts, what?
Choose a graph on the paper.
No. The person you trade with is gonna be able to draw any graph they want. But you'd be assuming it's linear.
I know, but if it's non-linear, then you really won't be able to easily give us a slope.
I could have like an outlet of the equation, so like I wouldn't say like fill it in, but I'd say we just like say like y, like the quadratic for out of the.
Well, you're asking questions. So I don't exactly know what you're asking me. How could you phrase that as a question to the person who has the graph? I mean, sure, but that gives you a point.
What are the points?
Oh, what are the points? Well, you can't give all of them.
But like
Okay,
one
so
over
if it's exponential, you literally can't give all of them. You run out of life. Same thing with quadratic. Same thing with a continuous linear function. I mean, it goes on forever, right? So if you want to describe the entire graph, you have to tell them like when it just continues with that behavior. Or that
okay. What?
When you've written all the questions that you would like to write, I'm not rushing. I know some of you work fast. When you've written all the questions that you would like to write, go ahead on graph paper, create whatever graph you want. But it has to, like, it can't just be ridiculous. It has to be a function, has to follow behavior that we can talk about, can't be broken, so it can't be piecewise like linear then quadratic or linear. Like you can't have two different graphs because that's still a function, but it's two different graphs. Between -2 and +2, it's a linear increasing function. After +2, it's a quadratic. No.
My graphs are beautiful.
And then I'm going to come around and collect those laminated graph papers just to get them back in my resource page finder. Thank you very much. I'm going to laminate more things this year.
My kids are furry and have
Yeah, sometimes it seems kind of honest.
Trying to steal it. Yeah, sorry.
The other day,
You were bored?
So you decided to take it? I'm
he's
bored.
gonna take it
Steal
and
this.
borrow it and reprint it and sell it everywhere. All day.
CVM resource page 224. 124. Doesn't matter if the people at your table can see it. We're gonna switch. Alright, I need to start limiting this. You have 3 minutes to finish your questions and draw a graph. 3 minutes.
Yeah, because one question I have to do it.
No, thank you.
You'll find out. I made a graph for one question in particular because it would be so funny.
Don't know if that's gonna work.
No.
It'll be so funny.
It's called songs that open.
So funny.
1 minute, 1.5.
That's my graph. You know what I did?
What
What is it?
Oh,
Are you copying us?
To say the least. Writing on the
Wait, no. I got it. Remind me when I get.
Your question.
Oh, okay.
Oh wait, we're supposed to do that on a separate page.
Oh, it doesn't matter.
Oh well.
Ethan, you got a graph?
What?
Do you have a graph made?
Yeah, just a second. Yeah, I do have mine made.
All right, so I'm going to do an experiment here. I took Ryan's questions. I'm going to ask them to Ethan and try to create whatever graph Ethan has back there. I did not look at Ethan's graph. All right, Ethan, does it go through the origin?
No.
That question is now not helpful. Is it linear?
Well, yeah. Yes, it is.
It is linear, okay. Is it discrete? Well, that question now doesn't matter because I've already know it's linear. Does it have x intercept? If so, what?
It does have an x intercept. Wait, no, it does not have an x intercept.
Okay. Does it have y intercept? If so, what?
Yes, it has a y intercept of 1.
Now I can finally put something on the page. A y intercept of 1. All right. Does it ever end?
No.
Does it have more than one x or y intercept?
No.
So it's linear, does not end, has a y-intercept, and has no x-intercepts.
Yes.
Okay, then I am going to assume
Yeah.
Correct.
Really?
Yeah.
it is that. So, get up. Hold up.
Is it linear?
Now, Ethan, draw a new graph real quick, because now everyone knows your graph. Draw a new graph real quick. So, get with a different partner. I don't care where you guys do this at. Get with a different partner and play this both ways. Ask your questions to them. Have them try to, or you try to draw it, then switch roles. Have you ask them.
Yeah.
Now, there will need to be a group of 3 still. There will still need to be a group of 3.
Oh, these yours, Drew!
No, you can't be in my group if you know what I'm doing. You can't be in
There will be a group of 3. There will be a group of 3.
I need to
You took a while to start writing down questions. I think you stopped for a while. Now you're breaking rule number 1. And maybe we'll get back to Jenny's learning. By the way, Ava, you want this or are we recycling this? You were absent when I passed that grade. I was going to get forgetting. Okay, it's not my Alright, so you just go first. If you're at the bottom of the list and you know that you would have asked more questions, just ask them. They don't have to be written, but you are kind of wasting time. Yes!
I forget what kind of grass this is. Oh, here it is. The name. Not necessarily. Okay. Absolute value graph.
Absolute value graph.
Is it linear?
Oh, okay. Yes. Yes. What is the last thing?
Is it linear and decreasing?
So, okay, point of information, by the way. Point of information, sorry I have to interrupt. An absolute value graph is a linear function, but it's also piecewise because its behavior is broken. So just FY, because remember, piecewise does not just mean step. Step functions are a type of piecewise. Piecewise means broken graph. So when the absolute value changes direction, it's piecewise. But each section on its own is linear. So it's a linear piecewise. So if you're trying to answer questions and describe things,
Okay, here's
4 taps you that. Okay, go.
If you draw this correctly based on the question,
Not like directly on
you asked like 2 helpful questions.
So there was like
No.
what's the y-axis is like around negative half. Linear negative.
It was the other way. Yeah.
8.25.
Okay.
So what could you have asked then that would have clarified it? Or like where does the step happen? Where's the included point? Where's the... So you could say like, where does the step start and end? And he gave you that. But that's like once you know it's a step function, then you can think of those better questions.
Okay.
So you get 9. What kind of graph is it?
If your graph comes out different, figure out what other questions you could have asked.
Okay. What is the x-intercept?
You got 3 minutes. We're gonna bring it all back together.
What's the y-intercept?
Okay, based on that, I think
I feel like we're playing basketball.
Okay, so
Does he have a mustache?
nonlinear.
Is he wearing a hat?
The y-intercept is once I heard about it.
it's not going to be perfect, but
Okay.
Got
Is
it.
it increasing or decreasing?
Is it called like what's the point where the start date called? Okay.
What is the
Point
x
where the
line?
line is linear. The x is comprised of straight lines or a straight line. What's the
the sickness one is
I think there is a technical name, I just forget.
Name several
quadrants does it cover? Define several.
Yeah, I forget my first.
okay, is this your graph?
Okay. No. Get straight. Okay. Better. That's time for you to ask me. It has to be Ethan. You can ask me what graph it is. You can ask me so I can actually ask.
Okay, what is the slope?
Alright, slope
Is it impossible to make all of them?
What's the y?
Is it linear? No. Okay.
Little under a minute. Try to wrap it up.
But it's linear.
If your graph was like this,
Doesn't have a line. What?
yeah.
It does. I know. There's no line.
The other
Well, I do
like
that was the minus that. Would you say that you're pretty close? Like minus?
Yeah.
It's 5.5. So it has to go straight too.
What she says.
Oh,
is-
never said.
Oh,
Never
yeah,
asked the line
ooh,
question. No,
okay.
you didn't.
Okay, so that's
Point.
Like,
All right, let's bring it back in. I want to know.
Oh, I see.
I want to know.
Yours was
I assume you know what? That is
Telling
what
you about
I assume.
All right, I want to know what gave you issues if you were on, actually really either side, whether you were asking or receiving or, what gave you issues? Jenny?
When Gunnar asked me stuff but he also didn't ask me a really important question that made him lead on to
What question is, what should you have asked him?
He should have asked if it was discreet or not.
Yeah.
So you think one of the first things we should ask is discrete?
Yeah.
Yeah, because then I feel like it goes on from there, whether or not it's linear or a parabola or whatever.
So really, discrete, linear, if we could kind of somehow get them to tell us what type of graph is this. So we could really ask what type of graph is this and find out whether it's discrete or linear or quadratic or. There you go. Ava, what else?
Finding the x and y intercepts.
Ooh, intercept points are pretty good. As you hopefully noticed when I found out that I had a continuous line that had no x-intercept, what did I know?
That it was gonna be.
Slope of 0. Slope of 0. And contrarily, if we had no y-intercept, it'd be undefined. Very good, Gunnar. What else? Actually, intercepts. Pretty important.
If it is continuous or not.
Yeah, so still kind of like that. So behavior in a way. If we can ask a question that explains the behavior of it, growth or decreasing or all that. What else? Slope and that kind of goes with behavior. Points. A couple individual points. So especially don't just ask for one. What's the minimum and then what's the better for points that can help you figure out your behavior?
Points on the graph.
Colin?
The minimum that you need is 2, I believe.
Really? To start to figure out any behavior, you need 3. In order 2 points, we could think are linear or quadratic or extra. We don't know how I'm getting from point to point. Once I go point, then I see does it make a line, does it make a curve. So 3 is the absolute minimum. Better would be 5.
For some, you need minimum.
Why not all what's going on?
Yeah, some really 5 is kind of like the minimum.
I drew
What-
a really kind of weird one.
What do you think the point of this activity was? Ah, did not even mean to do that. What do you think the purpose of this activity was? Chris?
To be able to describe graphs and make sure that you know how to ask correct questions.
Think more broadly.
Okay.
Jenny? You're right, but think more broadly.
Key elements of the graph.
Think more broadly. Ava?
Communication. Connections. Stop teaching other classes.
So, mathematical communication is tough. There are a lot of pieces and parts that go into it, and we all think about it differently. Our brains are all hardwired differently. So as we go through this class and as we communicate with each other, we have to understand that we're not all on the same page all the time, and sometimes we have to give excessive amounts of detail to get other people to see what we see simply, like what we see easily. So, as we move forward, think about question asking and ways in which we answer to make our mathematical communication effective. Cool? That's all I got for today. Homework same as yesterday. Tomorrow we will move forward. Have a great day, guys. Thank you for entertaining me.
Thank you.
I had that as a document.
My graph starts with these ones.